Welcome to The Explainer. Today, we're going to pull back the curtain on the statistical engine that powers one of the biggest ideas in finance, modern portfolio theory. It all boils down to a really powerful question. How do two different assets actually relate to each other? So, let's just kick things off with the million-dollar question, right? It's something every finance student and honestly every investor has to ask themselves. How in the world do you build the perfect portfolio? Where do you even start? Well, the most obvious answer, the one that just feels right, is to find the stock that's expected to give you the biggest bang for your buck and go all in. Find the fastest horse and bet the farm on it. But, and this is a huge but, that simple logic can be dangerously wrong. Okay, let's make this real. You've got two choices, stock A and stock B. Stock A has an expected daily return that's 10 times higher. Based on our simple rule, this is a total no-brainer. You'd pour every dime into stock A. So, why might that be a huge mistake? Here's why. The real magic, the core insight of modern finance, isn't about how a single stock performs all by itself. No, it's about how different stocks perform together. Their relationship, that's the secret ingredient. So to even begin to build a smart, modern portfolio, we have to understand the relationship between our assets. And to do that, we need a map of every single possible outcome for our two stocks. And in statistics, this complete map has a name. It's called a joint probability distribution. Okay, now what's so cool about this table is that it shows us the chances of two things happening at the exact same time. Just look at the bottom right corner there. See that? There's a 20% chance that stock A has its best day, a 2% gain, and stock B has its best day, a 1% gain, on the very same day. This table right here holds the key to their entire relationship. So we have the big picture of how they work as a team, but what if we want to zoom in? What if we just want to know the odds for stock A all by itself, completely ignoring what stock B is doing? Well, we can actually pull that information right out of this table. It's actually incredibly simple. You just sum up the rows to get the total probability for each of stock A's outcomes. We call these its marginal probabilities. You can see right there, there's a 35% chance of a plus 2% day for stock A, period. And if you sum the columns, you get the same thing for stock B. We've just isolated each stock's individual story from their joint one. All right, this is where things get really, really powerful. Now we can start asking those sophisticated what-if questions. Like, what if we wake up and we already know stock A had an awesome day? How should that new piece of information change what we expect from stock B? And this brings us to a super important concept, a conditional distribution. Now, that formula might look a little intimidating, but all it's really saying is that the probability of Y happening, given that we already know X happened, is just their joint probability divided by the probability of X. It's basically a way to update our odds with new intel. And boom, look at this. This is what that formula gives us. On any given day, stock B has a 35% shot at a 1% gain. But on days when we know stock A just shot up by 2%, stock B's chance of that same 1% gain jumps all the way to over 57%. That tells us loud and clear these two tend to move together. Okay, but let's be realistic. Working with these big probability tables all the time is, well, it's a pain, especially if you have more than two stocks. So finance pros came up with a way to boil this whole complex relationship down into one single elegant number. We need a shortcut, right? We need one single metric that tells us, at a glance, both the direction and the strength of the connection between two assets. So, the first step on that journey is something called covariance. A positive covariance confirms what we already saw. Our two stocks tend to move in the same direction. The problem is, the raw number itself is really hard to interpret. Is a covariance of 50 a lot? A little? It's not immediately obvious. So to fix that problem, we standardize it. We scale that covariance number down to create a much more intuitive metric, the correlation coefficient. You'll often see it written with the Greek letter rho. And for our two stocks, that number is 0.348. And this number is just beautiful because it always lives on a scale from -1 to +1. -1 means they move in perfect opposition. +1 means they move in perfect lockstep. Our value of positive 0.348 tells us there's a moderate positive relationship. They tend to move together, but they're not perfectly in sync. So we just did all that math to get one single number. Why? What's the big payoff for knowing that correlation? Well, it is the mathematical key to unlocking one of the most powerful concepts in all of finance, managing your risk. And this formula is where it all comes together. I know, it might look a bit hairy, but it's the actual blueprint for portfolio risk. And I want you to notice something. It's not just about the individual risks of each stock. That's the first two parts. The absolutely critical piece, the secret sauce, is that last term, the covariance term. It mathematically proves that the relationship between the stocks directly changes the total risk of holding them together. And here it is. This is the magic. This is the payoff. Look at this. By combining asset 1 with its 15% risk and asset 2 with its 20% risk, we can build a portfolio that is actually less risky than either one of them on their own. The combined risk is only 13.6%. That is the power of diversification, right there in one chart. So the huge takeaway here is this. Smart investing isn't about being a great stock picker. It's about being a great portfolio architect. It's about understanding and combining assets whose relationships, whose imperfect correlations, build something that is way stronger and more resilient than any single asset could ever be on its own. Which leaves us with a final and absolutely critical thought. We build all these beautiful models based on historical data, on relationships that held up in the past. But what happens when a major crisis hits and all those carefully measured correlations suddenly break down and go haywire? Well, that's the moment when theory smacks into reality and the true art of investing really begins.